In this episode of Threading Thoughts, we talk about digitizing healthcare. Digitization can potentially impact every aspect of care delivery and operations. It enables efficient utilization of time and resources and allowing more time spent on patient doctor interaction. The concern, however, is the accuracy of a software in understanding terminologies and how much of training a healthcare personnel has to invest in to get the desired results. While technology has been a part and parcel of revolutionizing medicine, concerns of patient safety and data accuracy linger. Gaurav Gupta leads the business team at Navia and is passionate about building a quality solution for healthcare industry. He likes to experiment with different business models to understand what works and what doesn't work. Eventually, evolving a business model that has high growth potential and is sustainable. Gaurav is an MBA from the Indian School of Business and an engineer from NSIT Delhi. He specializes in strategy, business development, and marketing. Prior to Navya, Gaurav has successfully built two sustainable businesses, one being an enterprise solution for large enterprises and the other being a consumer product. Gaurav has also worked in management consulting where he advised pharmaceutical companies and hospital systems on strategy and operations management. Hi, Gaurav. I'm so glad you were able to join us for this episode of Threading Thoughts. Thank you so much for taking time off.
Thanks a lot, Mridula. It's a pleasure to be here and looking forward to having a good conversation.
Thank you so much. Voice-based virtual assistant systems learn from the doctor's behavior, right? And then they start suggesting commonly spoken or written data points for the doctor to simply select from. So, do you think this would decrease the personal time a doctor would take with each patient and replace personal touch with, efficiency and speed, perhaps? What are your thoughts?
Actually, that's a great question. I would say the whole healthcare ecosystem is the core value of a healthcare ecosystem is patient outcomes. Everybody's objective in healthcare ecosystem is patient outcomes, and for a doctor to improve patient outcomes, the core role or core work for the doctor becomes patient care. So if patient care as one of the core values that doctor is bringing onto the table when they speak to the patient, then ideally they should spend as much time as possible in for patient care and not for anything else. But at the same time, the importance of longer term patient care basically is very high. In if you look at a very short time period, if you look at one consultation, then ideally the whole of my time should be spent as a doctor. If I'm a doctor, all of my time should be spent in front of the patient and not doing anything else. Probably just a few seconds to write the prescription. But if you look at longer term, then I need for the long term better care of a patient, I need good records availability of the patient. I would need records from multiple sources so that I can see, analyze those records and take better decisions. I need to see the trends of how the health is improving or not, so the right actions can be taken. So we need to also look at the time spent by the doctor in understanding the trends of the patient's health outcomes. So what has changed after certain interventions have been taken up by the doctor. For example, after a surgery. So after a surgery, it becomes a very close watch for the first few weeks to look at the patient numbers and how things are changing. So from that perspective, time has to be spent on a system wherein the records of the patient needs to be there. So the importance of record keeping is what I'm trying to derive at that. So electronic medical records or any sort of patient records, which are called PHRs as well, patient health records, become important in case of long-term patient care. So what as now coming to the question with respect to the time taken on a system versus time given to the patient entirely. So we need to find out which system is the most efficient system for the doctor now. This is the second step. So first step, we have established that there is some importance, or there is a significant importance of patient health record. And second, now we are coming to the point that how do these patient health records, how do we basically capture these health records? So ideally, the most efficient way to capture these health records would be wherein there's no additional input required either from patient or the doctor, and the system is automatically capturing everything that you are saying in the clinic, right?
So you're saying a very
in
comprehensive data gathering, right? So that nothing is in the translation.
Yes, nothing is lost. And even if you are if you want to do selective gathering, but I'm trying to say where neither doctor nor patient has to spend time onto the system at all. So system does everything by themselves. But that is something which probably is a little far-fetched with respect to where technology today is. So what we are trying to do here is we are trying to come up with this. We have come up with a solution which is a voice-based solution, wherein the doctor doesn't have to spend a lot of time typing. So if you look at the healthcare ecosystem in the US, there's the research reports. Basically, there are a lot of researches available wherein they say that doctors have spent close to 55% of the time in front of the computers, right? So they're spending a lot of time in typing, and that increases the cost of healthcare and reduces the care quality at the same time. But in India, we can't afford that. Our doctors at patient ratio is quite bad. We are at 1:1,500 approximately. One doctor for 1,500 patients. So what we need here is much more efficient system. And if we ask doctors to type in the way they do in the US, it would become rather counterproductive for everybody in the ecosystem. So is required is solutions which are faster, more efficient, and it requires least doctors' time to be spent. So the system that we are talking about is voice-based, wherein doctor can speak. Right now, it doesn't capture anything and everything doctor speaks, but doctor has to click on a button, on a small mic button on the system or on the phone, and then they can speak about a complaint or a diagnosis or a medication regimen and so on. And the system captures what the doctor speaks, and system also has capability that it can transform that statement that has captured into structural data. So basically there's an engine running at the in the behind of the system, which basically converts that statement sentence into a structural medically relevant data and puts it into the system as a record, as an electronic medical record. So this is how we're trying to bridge the efficiency gap using voice.
So you're prioritizing when and where the doctor spends his time. It's more him, use less time in front of the computer, updating records, which still are incredibly important for the patient. But at the same time, you want him to spend more time with the patient. So you need a system that is, smart enough and quick enough to pick up on whatever he's saying as well, right? So, and then the system will be able to put it into slots, as in, medically what slots are necessary, where it should. Okay, that's really interesting. But voice-based virtual assistants might misunderstand the commands, right? As they depend on a training set. So what is involved in the correction?
Yeah, again, a very interesting point that these technologies are self-learning, as you know. These are deep learning based, machine learning based. So these technologies. So I mean, everything is a subset of artificial intelligence. So basically, they keep on learning from the feedback received from the user itself, and keep on improving itself in two ways. One is for that individual user, and second is from the global set. So both ways it will keep on improving itself and come close to 100% accuracy. So in this system, and what works is that it is a real-time digital system. So what you speak, you see in front of you as a doctor. If you say that the patient has headache for the last 3 days, or a patient has a mild headache for last 3 days, for example, then you can see that the system has captured headache into one box, in mild into second box, and 3 days into third box. So this structure, you can see the structure, or real time it is capturing it. And now you as a doctor can make the change. If for example system has captured something incorrectly, instead of 3 days system has captured 5 days, you can make the change immediately. Instead of mild, if the system has captured severe, you can change it right there. So with this feedback, system keeps on learning as we go forward. So this is where the real time learning happens, and there's no lag and there's no third party involved. So as a doctor, I am training my system myself, so that the system becomes very personalized to me. So in a way, Navya becomes my assistant and starts understanding what I'm trying to tell Navya without having to bring any third party in between. So that is the way wherein we look at going forward for this.
And I'm interested to know, how easy did doctors find this training, given that they're doing it themselves? Did it actually, if they're doing it when the patient is there, were patients a bit irritated initially? Because generally, you wait hours and then you get these 5 minutes with a doctor. So you want attention completely to yourself. So has that been also some feedback that went into the learning initially, or?
Yeah, absolutely. I mean, that's a very important point. When we think about it in a closed room, we think that user will be able to do it, but when you actually see the real-time user experience, it is very different. And as you see, if even in case of a system like this, if as a patient I see my doctor speaking to a machine, I might be a little uncomfortable, right? So that happens, there's no doubt about it. So what we do is we actually ask doctors to spend some time onto the system after their OPD is done. So they spend like half an hour or 15 minutes for a few days onto the systems. What we have to look at the behavior of a user here. So from a behavioral perspective, the doctors are used to writing using a pen and paper, and they're very comfortable doing that. They have been doing that for since the childhood. So during schooling, during college, undergrad and postgrad, all the doctors and all us as people have been doing that for a long time. So if we look at a behavior change and suddenly ask a user to move from handwriting based system to a completely different system, that sort of becomes a little uncomfortable for a user, howsoever easy it may make their life be. So we need to sort of come up with a middle ground here, where the user is comfortable in changing the behavior, and it is gradual in nature. It's not instantaneous, but gradual in nature. So for that purpose, we have introduced a middle layer also into this, where after understanding the user behavior, that there's a click-based system, where it is again a very smart system, where it learns from what kind of medication prescribing patterns you have, and you can click, and with a few clicks you can create a prescription or a medical record. So now what doctors do essentially is they use click-based system and they use voice-based system in tandem, depending on the requirement. So they would use voice-based, where there are longer notes and they would want to capture the entire note, and they would use click-based, where there's smaller clicks, like there are very smaller options to select from, so that they don't have to speak out there. So it becomes a place where it is like best of both worlds for the doctors, and they take least amount of time required to create a record as compared to the current scenario. So we have seen cases where the most exciting part comes when the doctor says that my handwriting, I don't like handwritten anymore. because there, that is where the real entrepreneurial satisfaction comes in, that the product that we are creating is actually helping them, because the value proposition comes in with respect to the time saved, efficiency, and with respect to what you can do with the data that you receive now as a doctor. That there's a lot of analytics that you can do. You can understand your prescription patterns, you can understand your patients' behavioral patterns, what kind of patients come into your clinic, etc., etc. So from that perspective, what you can do with the data also becomes very important. And one more important thing that comes in with respect to this is that even in the prescription now, because it is much more legible, it actually is very helpful for the patient. So
I was just about to tell that, Gaurav. There is no way I understand any doctor's prescription.
Yes.
It's a mystery, right? Even for a lot of pharmacists, the moment you walk in there, you're not sure what it is called, the doctor.
Yeah.
So this is a boon in disguise. I was just about to ask you that. Yeah, go ahead.
Yeah, absolutely. And there's a very little small feature that we have in the system wherein you can change the language. I think that also is very helpful in this case. So that sort of adds a good amount of value for a doctor, that they can just by a click of a button do that. So that becomes a good value addition there.
And that's lovely, because I think these are such practical applications, right? Literally things that we face day to day, and that's solving so many of them. And so how would you deal with, when you spoke about different languages, how would you deal with vernacular challenges in say a tier 2 or a tier 3, and as we update patient records, right? Or creating a smooth hospital workflow, or even optimize patient wait times, especially in vernacular. How do you do that?
That's a very important point. Like right now, also we are dealing with a lot of doctors who are in tier 2 and tier 3 cities. So about 60% of our users sit out of tier 2 city and tier 3 cities, and across the country we have a majority of our users are, I mean, the top performing state for us is Tamil Nadu right now, and majority of our users are from Tamil Nadu, Andhra Pradesh, Telangana, and Karnataka. These four states. Then we have a huge user base in Bengal, and all the states are very regional language focused states, right? With respect to understanding. And if you look at even in North India, we have users from Eastern UP, wherein Hindi becomes very critical, where Lucknow and Varanasi. So from that perspective, your question is very important, that how to deal with the patients with respect to different languages. But one unifying factor across the whole thing is doctors, and all the doctors are in a habit of writing prescriptions or thinking about their medical thought process. Their thought process is in English, because they have been taught medicine in English. So they have taken that 5 years to 10 years studies in completely in English, and everybody is cutting across the same language there. So for doctors, it becomes in a way very easy for us to make the system in one language, and they're most comfortable in English. But now, as I said, with respect to the output of the prescription, that is where it becomes important to have different languages. So we have introduced about 9 languages into the system, where doctor can basically, after writing the whole prescription in English, a lot of doctors have a habit, like if they write a prescription on pen and paper, what they would do is they would write in English, and then they would put a small note in Hindi. They would write that like 3 times a day, it translated into Hindi is din mein 3 baar. So they will write in din mein 3 baar in Hindi. For the patients. So now what we have done is we have basically made this into Hindi. So just by a click of a button, they can have this entire prescription with respect to the instruction given to the patients into Hindi. So anything that is written, for example, the medicine name or diagnosis, that is not translated. because that is where it is for the doctor per se, and or for the pharmacist, and we don't want to create that kind of it might create an ambiguity or a misunderstanding. So we avoided that, and only instructions like 3 times a day or 2 times a day, afternoon, morning, before lunch, after lunch, etc., is in the vernacular languages. And that is something which which we built after the feedback that we got from the users, because again, users essentially tell you what to build. So users told us that this is something which is very, very important, and without this I have to actually write using my pen. So again, if you can build it in, and we did that, and we're seeing a lot of prescriptions coming in vernacular.
So customer is king, huh?
Customer is king, yeah.
No, but that is so important, because you correctly mentioned it's not the medicines per se. The medicines perhaps is standardized, but when I have to take it is something that I have to understand. So not everybody will understand, and there might be, for example, I might not know to write in a language or to speak in a language where I'm posted. Then I'll look for somebody to come and help me, and that is very impractical every time.
Yeah.
So that's very nice. But using predictive data analytics to improve patient outcomes, which is what your main aim is, it's a boon. But however, would it influence insurance providers or influence financial implications from the hospital's perspective for the patients?
It's a very interesting and forward-looking point that we need to sort of think about what is going to happen 5 years or 10 years down the line using these technologies. Once these technologies become ubiquitous in nature and everybody starts using them, so what happens then? So very, very interestingly, the whole sort of, I would say, the whole world is moving towards now outcome-driven patient care. So this is where we need to also start understanding what outcome-driven patient care is, and how that is going to probably change the whole ecosystem in the long run. So I would say, probably 10 years or 20 years in the future, the outcome-driven patient care probably will become a norm in a way, and every single payout essentially paid to any of the stakeholders in healthcare ecosystem would be probably if my outcome has improved or not. So it would be based on my outcomes. So again, nobody can predict what is going to happen, but this is something where we are probably moving towards that. And why it becomes very important is that you are from the industry, you have very, very good healthcare experience and understanding, so you would know much better than I would that a lot of the medicines that are today in the market have very low efficacy. By efficacy, it means how effective they are. On a size of 100 patients, are they effective only for 30 or 40? So even the most sold drugs like Humira are only 30% efficacy, right? 30 or 40% efficacy. So we need to look at it from that lens, that if I'm eating a drug, is it even effective for me, or is it a placebo effect that is coming in? So that is something which probably will take center stage as we go forward, and the whole data bit will bring in a very, very important transparency and understanding into the outcome of an individual per se. So that is where probably it will move to a personalized healthcare, personalized medicine also space, wherein you basically make a pill for a smaller set of patients rather than the whole population, right? So once you have much more data, right now it's black box, so I don't know how a patient sitting in Mumbai is different from a patient sitting in Bangalore, right? So there are genetic differences, there are environmental differences, there are a lot of differences, and same pill will not work for both. So if we have the data of smaller set of populations, we can do a lot of analytics and insight, and probably when it becomes normal and the data becomes ample in nature in our country, we should be able to move to a more personalized and outcome-driven care, where even, for example, a drug which would be probably drugs would be called, Crows in Delhi. So it's only for Delhi people because it affects that population, or Crows in Mumbai. So in a way, it would be effective for that set of population and would be created for that sort of population set. So this is something which I personally feel would become the direction that we probably will go to, and the whole larger incumbents will also have started thinking on those lines. They have started understanding the value of data. Especially insurance becomes a very a very important and key player into this, because if as a patient, if I am careful about my health, if I'm taking my medicines regularly, if I'm adherent to my regimen of my medication, if I am adherent to my exercise and my preventive regimen, lifestyle regimen, then I am a better candidate for an insurer. So ideally my premiums should be lower than a candidate who is not adherent. So so insurance is one player who would essentially play a very, very important role. And once there is good amount of data, this is already happening in a few Western countries, where it is linked to your Fitbit, for example. So if you are doing 10,000 steps a day, your premiums would be X. But if you're not doing 10,000, your premiums would be X plus delta X. So something like that. So this is something which will come in, and insurance will become a very, very important and key player in understanding data and taking decisions on data, because insurance directly is impacting you and I as individuals. So we will that would be the first use case, and probably second use case would be pharma, the one that I talked about earlier, where in pharma, which is in the longer term use case, that pharma building products for smaller sets of populations, and probably even in the future for individuals, with a 3D printed drug for an individual like you and I is different. A drug is different for you, and a drug is different for me. So that can also happen in longer run.
And it's almost like the two things, right? One is incentivizing patients to take care of their health, so their insurance is lower. The other one is almost personalized medication. Almost like the orphan drug developments are for a very small subset of the population. So this is even more personalized. It's hyper personalized to an individual. And it will be fascinating to see how that plays out in the future. That will be great.
And that's a great point that you mentioned about orphan drugs. So rare diseases also would be easier to solve, probably with a lot of data. Right now, we know, all of us know, that how difficult it is to develop drugs for rare diseases and even find the candidates for those rare diseases. So probably that would also become much more easier going forward.
I know. This has been fascinating, Gaurav. Thank you so much for taking time off. And you are a very, very busy man. So to join us, it's been a joy and very informative as well. Thank you so much.
Thank you, Mridula. It's been a pleasure talking to you, and I look forward to speaking to you in the future as well. Thank you.
Absolutely. Thank you.